Welcome, brothers, to this explainer. Today we're diving into something that's absolutely critical out in the field, mastering the exact standard operating procedure for calibrating total organic carbon analyzers in ultra-pure water systems. You know the deal. Whether we're supplying a CDI module that needs TOC below 0.5 parts per million, or we're feeding a high-stakes semiconductor line demanding strict limits below 5 to 10 parts per billion, accurate online measurement is literally everything. So let's get right into it.
Here's our roadmap for today. We'll quickly run through preparation and system pre-checks, hit the zero calibration process, tackle spam calibration for both TOC and TIC, and then cover span check and verification. Finally, we'll wrap up with returning online and SCADA, plus logging and troubleshooting.
All right, Section 1, Preparation and System Pre-Checks. I want to stress right off the bat that strict adherence to this prep work prevents massive headaches later on. Getting the spaceline right is the absolute foundation of a successful calibration.
Now remember, brothers, safety is totally non-negotiable here. When you're out there on the skid, you've got to be wearing your cleanroom lab PPE. We're talking a white coat, powder-free nitrile gloves, and safety glasses. You're handling hazardous phosphoric acid and persulfate oxidants, so treat them with respect. Follow the SDS strictly, never touch that beaker rim or sample tubing with your bare hands, and always wash up thoroughly afterward.
Let's talk chemistry. For your standards, you need TOC zero water with less than 5 ppb carbon. For the TOC span solutions, whether you're rolling with sucrose or KHP at 500 or 1000 ppb, they absolutely must be certified reference materials. Prep these only in clean, brown, low TOC glass or PTFE plastic beakers. Oh, and always double-check those lot certificates and expiration dates before you mix a single drop. Right before we actually calibrate, you need to check the analyzer's LCD touchscreen. Hop into the Maintenance and System Configuration menus and verify there are 0 active faults. Keep an eye out for things like code 30 for a TOC span cal fail or code 51 for TOC overflow. While you're at it, make sure the sample tubing is leak-free, there are no air bubbles, your flow rate is stable, and the waistline is completely clear.
Okay, the magic numbers to remember right now are 30 to 60. You gotta let the analyzer warm up for 30 to 60 minutes in a room sitting between 10 and 30 degrees Celsius. Don't rush this part, guys. It is fully required to stabilize the non-dispersive infrared detector, the NDIR, and the UV lamp before we do anything else.
Once warmed up, navigate over to the System Range Data and Stream Program menus. We're going to lock in our low-range parameters for UPW, specifically 0 to 100 ppb or 0 to 500 ppb. Go ahead and select the manual calibration mode and make sure to jot down the temperatures of your zero water and span standards before moving on.
Moving on to Section 2, Zero Calibration Process. Now, brothers, it's time to establish our baseline by running the zero calibration. This is basically where we tell the machine exactly what absolute purity looks like.
Here is the exact sequence. First, rinse your tubing and beaker at least 3 times with zero water to strip away any environmental contamination. Second, introduce that zero water into the analyzer. Third, hit zero calibration on the menu. Finally, you're going to run 3 to 5 continuous cycles. What we are looking for here is stability, meaning a deviation of less than 5 ppb between runs or less than 10% of your operation range. Our target is incredibly strict, less than 10. If your zero reading isn't coming in under 10 to 20 parts per billion, you need to stop immediately. Check your zero water quality, inspect that CO2 scrubber, look for any acid reagent contamination, and check for NDR detector drift. All right, Section 3, Span Calibration for TOC and TIC. With a rock-solid 0 recorded, we now test the analyzer's accuracy using our 500 ppb carbon sucrose, or KHP standard. It is super vital to understand what the machine is actually doing during this automated 6 to 10 minute cycle. It's a 4-step process inside. First, it acidifies the sample with H3PO4. Second, it sparges it with a carrier gas to strip out total inorganic carbon. Third, it oxidizes the organic compounds into CO2 using UV or heat. And finally, it measures that CO2 via the NDIR detector to calculate your TOC. Now, if your specific setup measures TIC, or total inorganic carbon, separately, you'll be using a sodium bicarbonate and carbonate solution. Pay close attention to the pH here. After acidification, the pH has to drop below 3, ideally targeting 2.0 to 2.5. This guarantees you're getting a total conversion of inorganic carbon to CO2 right before the sparging phase. Section 4. Span check and verification. So the span cycle's just wrapped up and you've logged your values in percentage error. Now we actually have to verify that the calibration was a success.
You're specifically looking for a green span check pass banner to pop up. But brothers, we do not stop there. It is absolutely vital to run an independent check solution, something like a 250 ppb carbon solution. This independent verification is what actually proves the sensor's linearity across different concentration levels.
You might run into a few roadblocks at this stage, so let's compare two really common errors. If you get a TOC overflow error, it means the sample has way too much TOC. You'll need to jump into the menu to either reduce your sample volume or increase the sparge time. On the flip side, if you see high CO2 in base, you need to check your alkaline reagents and your base CO2 alarm settings.
Let's hit Section 5, Returning Online and SCADA. Calibration is officially confirmed and verified. Now we're going to safely return the analyzer to the live RO or UPW stream.
Think of this as a split screen check. Go ahead and switch your valves back to the live water. Ensure the pressure test is switched on. Seriously, never leave that off. Let it run 3 to 5 cycles to stabilize. Now, check your local LCD screen against your central SCADA monitor. If your local screen is reading 4.2 ppb, your central control room has to perfectly match that 4.2 ppb reading through the 4 to 20 amp or digital output.
Brothers, do not forget to dial in these critical alarm set points before you walk away. A reading greater than 10 ppb needs to trigger the UPW loop alarm, and anything greater than 500 ppb triggers the CD feed alarm. Once that's set, update the calibration date in the system and schedule your next maintenance reminder for 1 to 3 months out.
And finally, Section 6, Logging and Troubleshooting. We have to document all our hard work meticulously for quality assurance, and of course, know exactly how to troubleshoot if we happen to fail the criteria.
These strict pass parameters have to be logged exactly on your physical calibration form. Your zero reading must be less than 10 ppb. The span error needs to be less than plus or minus 5% or 10 ppb, whichever is greater, and your independent verification needs to be within 10%. Make sure you write all this down in blue ink, capturing your lot numbers, expiration dates, sample temperatures, and your signature. Now, if those readings drift or you get hit with a fail stamp, follow this exact troubleshooting hierarchy. First, rinse the system with 0 water for multiple blank cycles. Second, check or just replace the CO2 scrubber. Third, verify your acid and oxidant haven't expired or gotten contaminated somehow. If that zero drift is still running high, it's time to request professional NDR or UV maintenance. And finally, check the reactor and sparger for any organic coating or scale.
As we wrap up this explainer, brothers, I want to leave you with one final thought. If your online TOC monitor reads a perfectly safe 4.9 ppb, but your hidden span error was actually 8%, is your UPW system truly safe, or are you operating blind? Meticulous calibration, following this exact SOP, is literally the only thing standing between pure water and a disastrously compromised product. Stay focused, stay safe, and always calibrate with precision.